Okay, so the next question is 6.18 para dichlorobenzene has higher melting point and lesser solubility than those of ortho and meta isomers. So if you see, this question is from isomers, and this is an important question. You can put a star mark because this question has already come directly as it is in CBSE board exam PYQ it is. So before going to the answer, you should know what is the structure of all, and structure only will give you the answer. So I have already given the structure over here. So this is ortho dichloro. If you see, ortho is this position, right? If this is a substituent, this is your ortho position, this is your meta, and this is your para. So dichloro, so there are both are same whole chlorine here. This is meta and para. Now they're asking why para has high melting point as compared to ortho and meta. Now obviously para here one chlorine will be there, so this is not there. Okay, so if you see here, this chlorine and this chlorine, they are as far as possible in this structure and they have a proper symmetry in it. Can you see it? Because of that, when in a beaker or in a solution, if you see, these para compounds can be easily, fitted together in a crystal lattice, and because of that, they have a very high crystal lattice structure, and because that is very difficult to break them. And to break them, you need to provide more heat. So this is the first of the reason why melting point of para is more as compared to ortho and meta, because of the symmetry and the crystal lattice tight structure. Next, they are asking what about their solubility? Why solubility is less? Remember, for solubility, you have to always check for the hydrogen bonding. Now we know that the haloarenes, these bond with the halogen is not that much polar because of partial double bond character, resonance, and all that we have seen before. So this is not that much polar, and because of that, they are not able to make a proper hydrogen bond with them. Because for hydrogen bond, you need to have this polarity, because that then only they can attract. Since hydrogen bonding is not that much strong as compared to the hydrogen bonding present between water molecules, so they are not able to dissolve properly. However, if you want them to dissolve, you have to use non-polar solvent like benzene, carbon tetrachloride, chloroform, and all that stuff. So this is the reason of their lesser solubility. So what is the ideal answer you're going to write for it? As we know, para isomer is more symmetrical. So this is the first keyword. As compared to other isomers, this means that in the crystal lattice, molecule of para isomers are more closely packed. And crystal lattice is again the second keyword for you. As a result, it has higher melting point and lower solubility as compared to ortho and meta. So lower solubility, you can skip here. You can just write higher melting point. Next, haloarene are less polar. This is the third keyword. Then haloalkane and are insoluble in water. This is because of lack of hydrogen bonding. So this is the next keyword. As a result, the attractive force in haloarene water system remains less. Haloarene and water they are talking about, between a haloarene and a water. And then attractive force between water molecules and hydrogen bond in it. So haloarenes are soluble in organic solvent, which is non-polar, with low polarity such as benzene, ether, chloroform, and carbon tetrachloride. This is your ideal answer. Thank you.